Okay, here's a concept that students struggle with to do with moles, and that's trying to figure out how many moles of individual particles we've got in a substance. And I've chosen 4 molecular substances here. That means that they exist as molecules. I've got helium, nitrogen, carbon dioxide and methane, and I've represented them as simple models with circles representing the different atoms. So if we can imagine having helium, if we've got 1 mole of molecules of helium, each molecule of helium only contains 1 atom. So if we've got 1 mole of molecules or 1 mole of gas of helium, we've only got 1 mole of atoms. But nitrogen, a diatomic gas, okay, which has got 2 atoms per molecule, then we have a slightly different case. If we've got 3 molecules of nitrogen, we've got 3 molecules of nitrogen, each molecule of nitrogen contains 2 atoms. So the total number of atoms, nitrogen atoms, is 6. Carbon dioxide, stranger still. Each molecule of carbon dioxide has got 2 oxygen atoms and a carbon atom. So each molecule of carbon dioxide contains 3 atoms. So if you had 2 moles of molecules, you would have 2 multiplied by 3 equals 6 moles in total of atoms. And that would be made up of 2 moles of carbon and 4 moles of oxygen. Methane, a carbon and 4 hydrogens. So if you had 4 moles of methane, 4 moles of methane gas or 4 moles of methane molecules, in total you would have 4 times 5, 20 moles of atoms, because each molecule of methane contains 5 atoms. That 20 moles of atoms is made up of 4 moles of carbon and 16 moles of hydrogen. 16 because we've got 4 moles of it and there are 4 atoms per mole. You can take that as well. That idea works with ionic compounds as well. If you imagine this is, for instance, sodium chloride. Sodium chloride, NaCl. If we take a simple representation, this is just a very simple for this exercise. Ionic substances do not exist as individual molecules, but to get an idea of moles, then if sodium chloride is made up of 1 sodium, 1 chlorine per mole of sodium chloride, then it contains, if you have 1 mole of sodium chloride, it contains 2 moles of ions, because there's 1 mole of sodium ions and there's 1 mole of chloride ions. If this was an ionic compound, it could represent magnesium fluoride, MgF2. So if we imagine having, let's say, 2 moles of magnesium fluoride, that contains 3 moles of ions. It contains 3 moles of ions. Well, it's made up of 1 mole of magnesium 2 plus ions, and it contains 2 moles of fluoride ions. 3 moles in total. Now, what about if we had something weird like copper sulfate? Now, we need to remember that copper sulfate contains the ions copper 2 plus and SO4 2 minus. SO4 2 minus is one ion. So if we had, for instance, 3 moles copper sulfate, we've still only got 6 moles of ions. And 6 moles of ions made up of 3 moles of copper 2 plus and 3 moles of sulfate. A last example up here on ionic compounds. If this was potassium carbonate, we can see again that the carbonate ion is CO3 2 minus. That's one ion. And there are 2 K pluses. So for each mole of potassium carbonate contains 3 moles of ions. Here's a molecule, complicated molecule. This is, well, if you're in my IB class, you know, I hope, that this is propanoic acid. What if we had 5 moles of propanoic acid? 5 moles of the acid. How many moles of atoms? 5 moles of acid, moles of atoms. Think about that for a moment, or even pause. Okay, 5 moles of atoms. We've got 1 here, 1 carbon. We've got 3 hydrogen. We've got 1 carbon, 2 hydrogen, 1 carbon, 2 oxygen, and 1 hydrogen. That gives us 11 moles of atoms. How many moles of carbon atoms? We've got 3 moles of carbon atoms. We've got 6 moles of hydrogen atoms. And we've got 2 moles of oxygen atoms. Okay, I hope that's beginning to make a bit of sense. Any questions? Come see me.